Hi, hello everyone, and welcome back to another video. Uh, for today's video, we are going to be diving a little bit deeper into angle relationships and sort of looking at some deeper algebraic applications of the angle relationships we've been talking about. So we're going to apply this new vocabulary we've learned, so things such as alternate interior angles, corresponding angles, right? And combine that with some of the older vocabulary we already knew with like vertical angles, what does congruent mean, supplementary, complementary. We're going to be looking at all those different things, and we're going to use those to define specific relationships between two angles, to prove lines parallel, and to solve for missing variables. So again, we are going to have this algebraic application, so we are going to be doing a lot with solving equations today. Sorry, that took forever. Okay. So the first thing we're going to do is point out what are the most common relationships between angles. So if we're going to be talking about solving based on angle relationships, I'm going to need to know what types of equations might I set up. So one very common angle relationship would be that two angles are congruent to each other. Okay, and as we should already know at this point, congruent means that they have the same measure as each other. So if two angles are congruent, the measure of one angle is going to be equal to the measure of the other angle, right? Congruent really just means the same. The next angle relationship that is very common would be supplementary angles. And if you remember from what we've learned before, supplementary means that angles are adding up to 180 degrees. So if you have two angles that are supplementary, then you would be adding two angles. And once you add those two together, they're equal to 180 degrees. The last really common relationship that we'll see is complementary angles. And again, if you remember what the word complementary means, it means that angles add to 90 degrees. So that means that if I take the measure of one angle and add it to the measure of another angle, that would add up to 90 degrees. Okay. So these are the different ways that we are going to be setting up equations today. It is possible that you might have some other angle relationship asked of you at some point. For instance, if you had an angle and the entire angle was given to you as like 68 degrees, and then you had two angles that made it up, and like one side was x and one side was 2x or something, like you could have a different type of equation, right? I could happen to know that those two angles add to 68 degrees versus one of these other angle relationships. But because these are the angle relationships that will make sense and most often be given, we're going to be focusing on them. So congruent, supplementary, and complementary. Those are the things that you should really be keeping your eye out as we continue through this video. So here we have a diagram and it asks us to solve for the value of x. So we can see two intersecting lines here, and on one side is the expression 2x plus 30 degrees, and on the other side says 7x minus 25 degrees. So I need to determine if these two angles are congruent, supplementary, or complementary. And the first step to doing that is going to be to identify the name of the angle relationship here. So we've talked about this extensively starting in the last unit, where angles that are across from each other at intersecting lines are always going to be congruent to each other. And we did this with the triangle congruence criteria and triangle congruence proofs so much. Remember that these are called vertical angles, again, because they are angles across from each other at the intersection of two lines. And when it comes to vertical angles, I know that they are always going to be congruent to each other. And I'm going to abbreviate that with just a symbol. And I know that congruent means that they are the same as each other. Or in other words, that they are equal to each other. Okay, the measures are the same. So if both of these angles has the same measure, that means that if I have an equation for each of them, and they have to be the same, they're going to be equal to each other. So I'm going to say that 2x plus 30 is equal to 7x minus 25. And from there, I can continue on and I can solve this equation. I want to get all my variables on one side and I want to get my constants on the other side. So my first step is I'm going to go ahead and subtract 2x from both sides in order to remove my variables from the left. And that'll leave me with 30 is equal to 5x minus 25. Next, I want to make sure all the constants are on the other side, so I'm going to add 25 to both sides. And that leaves me with 55 equals 5x. And then last but not least, I now have 5x equals 55. So since x is being multiplied by 5, I'm going to divide both sides by 5 to get rid of the 5 on the right. And that will leave me with 11 is equal to x. Okay. Let's look at this example now. When we look at this example, I'm seeing right away, the first thing that I personally notice is that we have a right angle marked here. So right here, you see that little box that's drawn in, that is indicating a right angle. And I know that a right angle is a 90-degree angle. Okay. And so if these two smaller angles are making up that right angle, they are complementary, meaning they add to 90 degrees. So here we have an example of two complementary angles. Okay. And again, complementary means they add up to 90 degrees. So when I'm going to go to set up an equation to solve here, I need those two expressions to add to 90. So I'm going to take the first expression, 4x plus 7, and then I will add it to the measure of my next angle, 35, and that will all add up to 90. As I solve in this case, I'm actually going to start by combining like terms. You can see on the left side, I have two constants, so I'm going to start by adding 7 to 35, just to sort of simplify. Leaves me with 4x plus 42 equals 90. Then I'm going to subtract 42 from both sides as I start to isolate x. Leaves me with 4x is equal to 48. And then last but not least, right now I'm multiplying x by 4. So to get x alone, I'm going to divide both sides by 4. And that leaves me with my final answer of x is equal to 12. It's also a good practice to get into to go ahead and check your work. So I'm going to do an example of that here. I'm going to plug my answer of 12 into this expression. And if I do that, I can figure out what the measure of this angle is. So when I add that, I get 48 plus 7, or in other words, 55. So it means this angle is 55 degrees. And if I look here, well, 35 degrees plus 55 degrees does in fact add up to 90. So my answer is correct. And I can be satisfied knowing that I'm correct before I move on to the next question. So I do always recommend that you do check your work like this when you solve problems like this. Okay. Here we have a set of two parallel lines. That is indicated to me by the fact that I have this given information next to the diagram. Line P is parallel to line Q. Given that I have two parallel lines, I'm supposed to solve for x and the missing angle measures. So you'll notice down below, I'm given the measure of angle 4 and angle 6. And I'm going to start by drawing those in on the diagram because that helps me to sort of visualize the angle relationships. So there is angle 4, and then angle 6 is 2x minus 7. Okay. Now that I have those written on my diagram, I can tell that these are same side interior angles. I know that they are same side interior because they are on the same side of the transversal and they are on the inside of my two parallel lines, okay, making them same side interior angles. And I happen to know that same side interior angles are supplementary, or in other words, they add up to 180 degrees. So as I solve for x, I'm going to set up an equation where these two angles add to 180. So I would take 62 plus 2x minus 7 equals 180. Okay. Again, I happen to have a couple like terms. I have two constants, 62 and minus 7. So I'm going to go ahead and start by simplifying that down to 55. I'm left with 55 plus 2x equals 180. Okay. And then from there, subtract 55 from both sides. Leaves me with 2x is equal to 125. And then when I divide by 2, I find that x is equal to 62.5. I'm going to go ahead and write that in here. Once I know what x is, I can go ahead and I can figure out what the measure of angle 6 is by plugging x back in. Alternatively, I wouldn't even have to do that. I could just go ahead and based on 62, knowing that that plus something else equals 180, I could solve it like that and just subtract 62 from 180. But since we already had to solve for x, I'm just going to go ahead and I will plug x into that expression, 2x minus 7. So starting with 2x minus 7, I plug in 62.5. Okay. When I multiply that, I get 125 minus 7. And that tells me that this whole thing adds up to 118 degrees. Okay, so I'm actually going to replace on my diagram that expression of 2x minus 7 with 118 degrees. And I know that's slightly illegible, so I apologize for that. Okay. So I know angle 6 evaluates to 118 degrees, so I'm going to go ahead and put that down here. From there, I'm actually done with all the algebra I have to do because with parallel lines, you know that the relationship between all my angles now is that I either have supplementary angles or I have angles that are congruent to each other. And since I already have my two different angles, 62 and 118, I actually know that every other angle in this diagram is going to be congruent to one of those two angles. So I'm going to look at the 118 for now, and I'm going to find all of the angles that are congruent to it. So first, I'm finding a vertical angle. And the angle across from angle 6 at that intersection of two lines is going to be congruent. So I know angle 5 is also going to be 118 degrees. Okay. I will find another congruent angle by finding the corresponding angles. So if I look at angle 6, it corresponds with angle 1. Angle 1 is in the same position as angle 6 at the next intersection over. So I know that angle 1 is also 118 degrees. Okay. And then from there, I know that angle 3 would also be 118 degrees because those two are vertical angles with each other. So angle 3 is also 118 degrees. At this point, I have all of the congruent 118 degree angles. So basically every other angle is going to be 62 degrees, but I want to just double check and make sure I've done everything right. So I'm going to specifically look and make sure that measure of angle 2 makes sense as 62 degrees. Well, if you look at angle 4, that is right across from angle 2. So angle 2 and 4 are vertical angles, which does mean that angle 2 is also going to be 62 degrees. And my pen is not writing super smoothly here, so I apologize for that. But measure of angle 2 comes out to 62 degrees. And that is all the angles we were asked for. Because this angle here also corresponds, you would know that that angle and its vertical angle here also both happen to be 62 degrees, but we were not actually asked that in this problem, so that wouldn't be totally necessary for you to write down. Okay. Moving on to this problem, I think it's a good time in this video where hopefully you can go ahead and pause this, try to solve for this on your own, and then once you finish, check back into the video to listen to the solution and check your work. Okay. But as I approach this problem, I can actually approach in a couple different orders. That is pretty much up to you. I noticed that I'm solving for 3 different variables. So I'm solving for x, y, and z. And I'm just going to look on my diagram right now to figure out where all those are. So I noticed that right here I have my x, right here I have z, and right here I have a y. So to me, it looks most simple to solve for z first. So I'm just going to start with that. I see that z is just the entire measure of that angle. I am, in fact, given that these two lines are parallel to each other. So I know that corresponding angles will be congruent. So I see how this 78 degrees here is a corresponding angle with z. So I actually already know, without doing any algebra, that z is going to be 78. Actually, not 78 degrees, just 78. This is a good time to clarify that. The measure is z degrees. So if z is 78 and I plug 78 into the expression z degrees, that makes the whole angle 78 degrees. So the variable is part of this expression. You wouldn't actually include the degrees there. Okay, the degree is just for the measure of the angle, not for the variable itself. As I move on to another part, I'm going to go ahead and I think both x and y, those are kind of expressions I'm going to have some algebra to do. So it doesn't really matter which order I do this in. Just because they list x first in the problem, I'm going to go ahead and try to figure out the relationship there. So I'm going to figure out how I can solve for x using this expression. Now, there's a couple different ways to approach this. I already figured out that this angle here was 78 degrees. So I could go ahead and say that those two are congruent to each other because I know that those are vertical angles. Or if you were trying to do this just based on the information originally given to you, you could be looking at this original 78 degrees here and notice that it is an alternate exterior angle with 4x minus 42. So again, those would be congruent to each other. Because the angles are congruent to each other, in order to solve, I set them equal to each other, since congruent means the same. Once I set them equal to each other, I'm going to go ahead and solve. I'm going to start by adding 42 to both sides to get all the constants on one side of the equation. And that comes out to 120. And then if I go ahead and divide by 4 to get x on this side by itself, to isolate x, I end up with x is equal to 30. So once again, I write here in the answer that x equals 30. And then last but not least, I'm going to go ahead and solve for y. So when I solve for y, I'm using this expression here. And I can tell that because that expression there is a linear pair with 78 degrees, I know that those two are going to be supplementary. I mean, they add to 180 degrees. So I'm going to write those two expressions. I'm going to add them together and then set them equal to 180 degrees. For steps first, I'm going to combine the like terms. So I'll combine minus 23 with plus 78, and that'll give me 25y plus 55 equals 180. Then I'm going to go ahead and subtract 55 from both sides, leaving me with 25y is equal to 125. And then if I go ahead and divide both sides by 25 to isolate y, that ends up leaving me with y is equal to 5. Okay. And so I put that over here in the little answer box, and we are done with this problem. Moving on, we have a couple more problems to look at. So first, looking at this question, it says, what value of x would prove that line W is parallel to line V? So you'll notice in this case, we're not given the fact that these two lines are parallel, but we're asked which value of x would prove that they are parallel. So go ahead, pause the video again, think about this, and then you can come back to check your answer on it. So when we are looking at this diagram here, I can see that the two marked angles happen to be alternate exterior angles. Well, I know that when lines are parallel, alternate exterior angles are congruent. Right? These are alternate exterior angles. Okay, so if the lines were parallel, those would have to be congruent. So if I can determine the value of x that makes those two congruent, then I'm going to know that these two lines are parallel. So what I'm going to do is I'm going to set this up the same way I would solve for x given these two lines are parallel, since I'm trying to figure out the value that would make them parallel. And that means that they would be congruent again. So congruent means the same as. So I'm going to go ahead and set these two angle measures equal to each other. When I do that, I get the equation 3x plus 60 equals 120. And then I'm just going to go ahead and solve. I start by subtracting 60 from both sides. That leaves me with 3x is equal to 60. Then I'm going to divide both sides by 3 to get x by itself. And I'm left with x is equal to 20. So if x is equal to 20, that would prove that lines W and line V are parallel to each other. Okay. And once again, for good measure, I think it's a good practice to always double check our work. So I'm going to go ahead and plug 20 in for x in this expression. And if we multiply 3 times 20 plus 60, that would simplify to 60 plus 60, which does give us 120. So we do know that these two angles both happen to be 120 degrees with x as 20. So my answer here was, in fact, correct. Now, this is our last slide that we are going to look at today. So in this problem, it's a little different again. It says, given that B is equal to 34, is line A parallel to line B? So here I'm trying to tell, are they parallel or not? And I'm given this value of B. So I have two angles here. This one is 2B minus 15. This one is 3B plus 25. I apologize that those are so small. Hopefully you can see them. Okay. And I can see that those two angles happen to be same side exterior angles. Right? Same side because they're on the same side of the transversal, exterior because they're on the outside of the two lines that we're trying to prove if they are parallel or not. Okay. I happen to know that same side exterior angles are going to be supplementary if my two lines are parallel. So basically, since they're asking me if they're parallel, I'm trying to figure out, are these two angles supplementary to each other? So do they add to 180 degrees? So I'm going to go ahead and add up these expressions and see what they are equal to. Okay, you could go ahead and plug in for B right away. What I want to do first is I want to see, I want to simplify it first. So I'm going to go ahead and combine like terms, and I'm going to take 3B plus 2B. Let that give me 5B, and then I'll combine 25 and minus 15 to give me plus 10. Okay, and I will say, does that give me 180? Okay, now I know what B is, so I'm going to plug in the value of B that I was given of 34, and I'm going to say 5 times 34 plus 10. Is that equal to 180? And if I multiply 5 times 34, I'm going to get 170, and then add it to 10. And this does, in fact, equal 180, right? If I add those up, I get 180 plus 180 equals 180. So this checks out. And is line A parallel to line B? Yes. They are parallel because when I plug in 34 for B, these two angles are supplementary. Okay. So given all that information, this video is pretty much over. I want to go ahead and check back in with our objective. So our goal was to use all that new angle relationship vocabulary to be able to identify relationships between angles, prove line parallel, and solve for missing variables. So we did all of that throughout the video today. We talked about different angle relationships between angles that are either congruent, supplementary, or complementary. And we also identified that language, such as same side interior, exterior, corresponding. And so we used that that vocabulary to determine relationships. We proved lines parallel using those angle relationships. And then we also solved for missing variables. So it was also a good algebra review. So we have completed the objective. So you guys should be good to go. If you are still struggling with any of this, feel free to go back to any part of the video that you need help with and come to class with questions prepared.